Hi everyone, welcome back to another video regarding your course MATH102B Differential and Integral Calculus. This is your instructor, Engineer Janaika A. Tapiador. So this will be the last module for the course, and it will cover the topic of integral calculus. So this will be the topic learning outcomes for the course. So this should have been module number 5. I'm so sorry. So at the end of the module 5, the students shall be able to relate differential and integral calculus, integrate algebraic functions, and apply integration in calculating area under a certain curve. And the module will consist of the following: your indefinite integrals and of course your definite integrals. For this particular video, we will only be covering your indefinite integrals, and for the next, that's the time that we will cover your definite integrals. So the topic for this particular module content is the following. You have your introduction, indefinite integrals, and of course your substitution rule. So as an introduction, it says here, integrals are the third and final major topic that will be covered in this class. So if you take a look at the video, that YouTube video that I linked before, your calculus covered actually 3 topics. You have your limits, your differential, and integral calculus. So this is the last part. And this module, or this particular topic, is devoted exclusively to finding and computing your integrals. And as I've mentioned earlier, we have 2 types of integrals. You have your indefinite and of course your definite integrals. So let's go to your indefinite integrals. So if you recall in the previous topics, if we are given the function of x or f of x and asking what the derivative of this function was, or rather in the previous topics, when we are given a function of f of x, we get its derivative. Now, with this particular section, we are going to turn things around. So instead of getting the function of x, what we do is, what function did we differentiate to get the function of x? Kumbaga, ano kaya yung pinanggalingan nung function? So baliktad na siya ngayon. Kung dati dinidifferentiate po natin yung function, ngayon hahanap, parang yung function na yun is na-differentiate na. Tapos hahanapin po natin yung original function. So parang ganun siya. Indefinite integrals or your integral calculus is actually the reverse of your differential calculus. So let's take a look at this particular example. So it says, the question is, what function did we differentiate to get the following function? So kumbaga, kung ito yung f prime of x mo, ano kaya yung original function kung saan natin na kuha itong function na to? So let's actually start by getting the derivative of this function to help us see how we're going to approach this problem. The derivative of this function, so pag kinuha natin yung differential or derivative of this function, we will get this. Diba? F prime of x is, diba, dapat medyo familiar na kayo dito, you will get 4x cubed, diba, ito yan. Then you get plus 3, and then of course yung 9 kasi is 0 po yung kanyang derivative. So the point of this was to remind us how differentiation works. When differentiating powers of x, we simply multiply the term by the original exponent and then drop the function or drop the exponent by 1. So ang gagawin naman natin kasi dito, kumbaga kung ito yung differentiated function mo, hahanapin natin kung saan siya galing. So yung kabaliktaran po nung function na yan. So that's what we will be doing. So now let's go back and work the problem. So let's start with this first term. So we got x raised to 4 by differentiating a function, and since we dropped the exponent by 1, it looks like we must have differentiated x raised to 5. Diba? Since kinukuha natin yung original, kumbaga kinukuha natin, or rather tinitreat natin to as a differentiated function, hahanapin natin yung parang original equation niya. So since x raised to 4 ito, so probably yung original or the differentiated function, dapat ang exponent niya is 5. Kasi kabaliktaran, di ba? So, however, if we differentiate x raised to 5, we would have 5x raised to 4. And we do not have 5 in the front of our first term. So, the 5 needs to cancel out after we differentiate it. So, di ba pag dinerive or kinuha po natin yung derivative ng x raised to 5, yan is dapat 5x raised to 4. Eh kung i-compare mo siya dito, di ba wala siyang 5? So what do? We get rid of that particular 5. So such that kung ang dinifferentiate natin na function is 1/5 x raised to 5, di ba ang makukuha natin is x raised to 4. So, ibig sabihin, ang integral po, pag integrate natin ang x raised to 4, ang value po na makukuha natin, or rather, ang variable na makukuha natin dito is 1/5 x raised to 5. So, for the second term, in order to get 3x, we would have differentiated 3/2 x squared. So, again, di ba, si x, manggagaling siya kay x squared. Pero kasi, pag dinifferentiate mo si x squared, magiging 2x. Eh, 3x sinandun. So, dapat, ang i-differentiate natin is 3/2 of x squared para ang lalabas na sagot is 3x. So, eventually, masasanay din kayo, class, when we get the integral of certain functions. It just needs practice. So, again, the fraction is there to cancel out 2. Diba? We pick up in the differentiation. Now, the third term is just a constant, and we know that if we differentiate x, we get 1. So, it looks like we had to differentiate negative 9x to get the last term. So, 9x, ang magiging differential niya pag kinuha mo is negative 9. So, ibig sabihin yung na-differentiate natin na term is negative 9x. So, if we put all of this together, it will give us the following function. So, ito po yung sagot. So, 1/5 x raised to 5 plus 3/2 x squared minus 9x. And just to double check, pag dinifferentiate nyo po ito, it will give you this function. So, if we do that, o diba? 1/5 magiging x raised to 4, 3/2 x squared, magiging 3x, and of course, negative 9 is equal to negative 9. So, it looks like we got the correct function, or did we? So, we know that the derivative of a constant is 0. And so, any of the following will also give f of x upon differentiating. So, kunyari, pag dinifferentiate mo to, yun pa rin naman yung lalabas, diba? Kasi alam natin na pag dinifferentiate natin yung constant, 0 po ang lalabas. Or kunyari, ito, may constant din siya. Ito pa din naman po yung lalabas na sagot, and so on and so forth. So, we have to take note, or we have to adjust our equation such that to give way for possible constant that is there when we actually get the integral. So, dapat po, ang sagot is ito. So, you have f of x is equal to 1/5 of x raised to 5 plus 3/2 of x squared minus 9x plus c. The plus c here is a constant, such that if you differentiate it, diba 0 po ang lalabas. So let's go to the formal definition of your indefinite integrals. So given a function f of x, an antiderivative of f of x is any function capital F of x such that f prime, capital F prime of x is equal to f of x. Sometimes kasi ang tawag po nila sa integrals is antiderivative. Kasi nga parang may function ka, tapos ang hahanapin mo is yung antiderivative ng function na yun. But sometimes mas prefer kasi na tinatawag siyang integrals. So, if f of x is an antiderivative of f of x, then the most general antiderivative of f of x is called an indefinite integral and usually is denoted by this symbol. So, yan po. So, the integral of f of x dx is equal to f of x plus c, and c is any constant. So, you should be familiar already with this particular symbol. This is your integral symbol. So, this is your integral symbol. Your f of x is called the integrand. X is called the integration variable. And c is called the constant of integration. So, yun lang naman po yung mga terms that you need to be familiar with. So, let's go to some properties of indefinite integrals that will definitely guide us para mas madali po tayong mag-integrate ng functions. So, first, the integral of k of f of x dx is equal to k, the integral of f of x dx, where k is any number. So, for example, you have a constant, tapos nandun siya sa loob ng iyong function. Actually, pwede mo siyang ilabas doon sa integral symbol. Tapos, ang i-integrate mo lang is yung function mismo. And second, if you have sum or minus symbol doon sa iyong parang function, pwede mo lang i-distribute yung integration symbol such that integrate mo sila isa-isa. So, kunyari, for example, f of x plus g of x dx, so pwede siyang maging the integral of f of x dx plus or minus the integral of g of x dx. And let's evaluate the following indefinite integral para mas madali po natin siyang maintindihan. So, of course, by property 2, diba, itong integral symbol is kumbaga, i-distribute natin, of course, pati si dx, i-distribute po natin yan. Such that you have the integral of x cubed dx plus, by property 1, kung may constant ka, pwede mo siyang ilabas. So, 2 the integral of x dx. Such that, diba, pag alam mo na ito, pag x cube yung function mo dyan, alam mo na galing siya sa x raised to 4. And such that, pag kinuha mo yung differential ng x raised to 4, diba, magiging 4x cube. So, to get rid of the 4 here, you multiply the function by 1/4. Diba? Para x cube lang yung makikita mo. That's such that ang integral po ng x cube is 1/4 x raised to 4. Of course, plus 2, the constant. And of course, the integral of x, alam mo na galing yan sa x squared, diba? And if you get the differential of x squared, you will get 2x. And of course, to get rid of the 2, you have to multiply it by 1/2, such that you have 1/2 x squared plus c. And of course, simplifying your equation further will give you 1/4 x raised to 4 plus x squared plus c. Again, don't forget the c kasi the c denotes any constant. So, yan po yung sagot. So, let's take a look at another example. Ay, nagmamadali. So, you have the integral of 6x raised to 5 minus 18x squared plus 7 dx. Again, by property 1, you could just distribute the integral symbol, and by property 2, you can put the constant outside. such that you will be provided with this particular equation. You have 6, the integral of x raised to 5 dx minus 18, the integral of x squared dx plus 7, the integral of dx. Tapos again, you get the integral of each function. So, x raised to 5, alam mo na galing yan sa x raised to 6. And you have to get rid of the constant, so you multiply it by 1/6. Minus 18, and of course, the integral of x squared, as you know, is 1/3 x cubed plus 7. And of course, the integral of dx, kasi alam mo na may function dyan, dx is x lang siya. Plus, of course, your constant. Such that, if you simplify this equation, you will get this answer. So, of course, magka-cancel yan. 18 divided by 3 is 6. So, you will get x raised to 6 minus 6x cubed plus 7x plus c. And let's take a look at another example para po masanay tayo. So again, by property 1 and 2, so you put the constant outside. So you have 4, the integral of x raised to 6 dx minus 2, the integral of x cubed dx plus 7, the integral of x dx minus 4, the integral of x. And then you get the integral of each of the following function. You will get, so si x raised to 6, of course, galing yan sa x raised to 7. So you have this. X cubed is galing kay x raised to 4. And then you have this. X is galing kay x squared. So you have this. Dx is galing lang kay x. So you have this. And if you simplify the equation further, you will get this final answer, which is equivalent to negative 4 over 7 times x raised to 7 minus 1/2 x raised to 4 plus 7/2 x squared minus 4x plus c. And let's go to the last topic of this particular video. You have your substitution rule. So, let's take a look at the more complicated example. So, kunyari, ganito siya. So, as you can see, para na siyang multiplication. If you recall, di ba kanina, parang ano lang siya. Yung properties na binigay natin is kung may constant lang at saka yung rather addition and subtraction lang. So, what if naging multiplication siya, just like this case? So, multiplication siya or kaya division. So, how would we integrate that? So, dito medyo challenging siya, although pag nasanay kayo, madali na lang din siya. So, what if we are asked to get the integral of 18x squared multiplied by the 4th root of 6x cubed plus 5 dx. So, we first let u be equal to a certain function. So, let u be equal to 6x cubed plus 5. So, kumbaga, sige, mamaya ako na ipapakita. So, you let u be equal to 6x cubed plus 5 such that if you get the derivative of this particular function, you will get du is equal to 18x squared dx. Diba? If you get the derivative of this, ito po siya. So, 6x cubed, so magiging 18x squared plus, since the derivative of any constant is 0, hindi siya kasama dx. So, 18x squared dx. And if you try then to take a look at our main equation, di ba ito siya, 18x squared dx. So, parang ililet mo yung isang function to be equal to a certain variable. Usually, ang ginagamit na u, such that pag kinuha mo yung differential ng function na yun, is makikita mo siya doon sa main equation mismo. So, di ba parang pag i-shortcut na natin, so the integral of 18x squared, the 4th root of 6x cubed plus 5 dx is equal to the integral of u. Kasi di ba this is equal to u raised to 1/4. Sinimplify lang natin kasi the 4th root is raised to 1/4 du. Kasi du is equal to 18x squared dx. And of course, u raised to 1/4 is the fourth root of 6x cubed plus 5. So, parang isi-simplify po natin yung function using our knowledge in algebra such that mas madali po nating ma-integrate yung function. Again, you let a certain, some part of the certain equation be equal to a certain variable such that if you get the integral of that particular variable, in this case, diba, makikita mo pa rin siya doon sa function para mas madali po siyang i-simplify. So, if this particular equation is equal to u raised to 1/4 du, in the process of doing this, we've taken an integral that looked very difficult, and with a quick substitution, we were able to rewrite the integral into a very simple integral that we can do. Kaya siya tinawag na substitution rule kasi parang ililet mo or magsa-substitute ka lang ng variable na ililet mo doon sa some parts of the function. And if we evaluate this particular integral, di ba madali na lang siya, it will give you, di ba, u raised to 1/4 and 1/4 plus 1 will give you 5/4. So, ibig sabihin, si 1/4, originally, kung kukunin natin yung antiderivative, it's u raised to 5/4. And since we need to get rid of that constant, pag differentiate natin siya, mag-introduce tayo ng 4/5 plus c. So, kung ito na po yung integral ng function, pwede na po nating ilagay cu back to the equation. So, kanina, di ba ang u natin is equal to 6x cubed plus 5. So, kumbaga ibabalik lang natin siya ulit doon sa u na yan. Such that we will get this final answer, which is equal to 4/5 multiplied by 6x cubed plus 5 raised to 5/4. Of course, do not forget the constant c. So, yan po yung sagot doon sa equation. So, what we've done in the work in the previous slide is called your substitution rule. So, in general, the substitution rule is like this. If you have the integral of f of g of x, g prime of x dx, then you may get the integral of f of u du, where u is equal to g of x. Dapat lang po na dun sa loob ng function mo, pag kinuha mo yung differential, is makikita mo yung differential doon sa loob ng function na yun. So, let's take a look at another example. So, you have the integral of x squared multiplied by 3 minus 10x cubed raised to 4 dx. So, simply looking at the equation, ano kaya ang ililet natin to be equal to u? So, kung i-check nyo, diba, itong function na to, or itong part ng function na to, 3 minus 10x squared, pag kinuha mo yung differential niyan, is mabibigyan kanya ng function na may x squared. So, definitely, we let u be equal to 3 minus 10x cubed. Then, du is equal to 0 minus 10 multiplied by 3x squared, or you have the negative 30x squared. So again, kung titingnan mo siya, di ba meron siya dito, 30x squared, sorry, dapat may dx yan. So 30x squared, i-correct ko na lang sa notes nyo. 30x squared dx, pero ang meron ka lang dito is x squared dx. So, ibig sabihin, may konti tayong problema. Nakuha nga natin si x squared out in the front of the parenthesis, but we do not have a negative 30. Diba? Kasi may negative 30 siya dito. So, this seems to be a problem at first, but we will simply rewrite the differential as follows. So, mag-introduce ka lang ng negative 1 all over 30 of the du para po, di ba, makonform siya na pag kinuha mo si pag kinuha mo si du, diba, du will simply be equal to negative 30x squared dx. Na-equal na siya dun sa equation natin kanina. Diba? Pakita ko, diba? Ito na siya, negative 30x squared dx. So, mag-introduce ka lang ng negative 1 over 30 du. So with this, we can now substitute the x squared dx away. In the process, we'll pick up a constant, but that isn't the problem since, di ba pag constant, pwede mo siyang ilabas sa integral. So kung yan po yung dati nating equation, so we simply substitute it with u raised to 4, kasi di ba yung u natin is 3 minus 10x cubed. Tapos don't forget, naka-raise siya din sa 4. And then of course, yung ating du, which is equal to, or rather yung ating x squared dx, which is equal to negative 1 all over 30 du. Such that, again, since pwede nating ilabas yung constant using property number 1, so you have negative 1 over 30, the integral of u raised to 4 du. So kung i-evaluate na natin si u raised to 4, alam natin na galing yan kay u raised to 5. And of course, introducing the constant, diba, you have this particular equation, and evaluating it further will give you this answer. So you have negative 1 over 150 u raised to 5 plus c. And of course, if we put back, sorry, kanina nakalimutan ko. If you put back the value of u, babalik mo lang ulit yung value ng u. So you will get this answer, negative 1 over 150 multiplied by 3 minus 10x cubed raised to 5 plus c. So you have this particular answer. So what if naman division? Tinailong ko, ano ba yan? So if you have division, say for example, you have this, the integral of 3 all over 5y plus 4 dy. So ano kaya, paano kaya natin paano kaya natin i-approach tong problem na to? So kanina, 'di ba, part pa rin kasi ito ng substitution rule. So kanina multiplication, ngayon naman division para makumpleto natin si MDAS. So this is what you do. So we haven't seen a problem quite like this one yet. So if you notice, if we take the denominator, 'di ba, pag itong denominator daw, and we differentiate it, ano ba ang differential ng 5y plus 4? Di ba magiging differential ng yan is a constant, 5 lang. Kasi 0 naman to. We would just get a constant. And the only thing we have in the numerator is also constant. So this is a pretty good indication that we can use the denominator for our substitution. Since kahit naman magkaibang constant yan, di ba pag constant kasi sa integration, di mo naman problema kasi you could always factor it out. So ibig sabihin, pag we let the denominator be equal to u, makukuha natin, pag kinuha natin yung kanyang differential, diba, it's always a constant, which is nandun sa numerator. So, if we let u be equal to 5y plus 1, or rather 5y plus 4, and if we get the differential of that, you will get du is equal to 5 dy, or your dy is simply equal to 1/5 of du. So, kinuha lang natin si dy, kasi ito, mamaya isa-substitute natin doon. The integral is now, diba, the integral of 3 all over u, yung u natin is equal dito, and yung kinuha natin dy kanina, which is 1/5 of du. So, eto ba? Ito yun. dy is equal to 1/5 of du. Such that, diba, pwede natin ilabas yung constant, diba, 3/5, such that you have 1, the integral of 1 all over u du, and rule po ito. The integral of, kunyari, 1 all over x dx, hindi ko kasi nailagay dito, 1 over x dx is simply ln of x plus c. So, lagi siyang ganito. So, if you take a look, very similar silang dalawa, such that if you evaluate the integral of this, you will get 3/5 ln of u plus c. And of course, plugging the value of u back to the equation will give you 3/5 ln of 5y plus 4 plus c. That is the final answer. So that's it for this particular video. The next topic that we will have is on definite integrals. So after the video on definite integrals, next meeting, that's the time po na bibigyan ko kayo ng activity para po minsanan na. Okay? So, that's it for this video, class. And I hope naintindihan nyo siya. And of course, yung mga bibigay ko naman po na activity, it will help you to understand this topic better. So please stay home, stay healthy, and stay safe. Goodbye, everyone.